In this chapter, we will study the properties of gases. An ideal gas is a theoretical gas composed of randomly moving atoms and/or molecules that are not subject to interactions with one another. The behaviors of ideal gases comprise the gas laws. Boyle's law is an empirical law that describes the relationship between pressure and volume of an ideal gas. Boyle's law states that the pressure of a given amount of ideal gas is inversely proportional to the volume if the temperature remain unchanged. For example, at 300 kelvins, the product of pressure and volume of 1 mole of helium, methane, and ammonia are almost a constant. But at high pressure, their products deviate from the constant due to increased interparticle forces. Charles's law is an experimental law that describes how gases tend to expand when heated. When the pressure on an ideal gas is held constant, the absolute temperature and the volume will be in direct proportion. Charles's law implies that the volume of an ideal gas will descend to zero at absolute zero. Gay-Lussac's law sometimes refers to the proportionality of the pressure of a gas to its absolute temperature at constant volume. Combining the laws of Charles, Boyle, and Gay-Lussac gives the combined gas law. For a given ideal gas, the ratio of PV to T is simply a constant. Combined gas law does not specify the amount of gas. Avogadro's law is an experimental law relating the volume of a gas to the amount, i.e., the number of particles. Avogadro's law states that equal volumes of all ideal gases at the same temperature and pressure have the same amount. If the temperature and pressure are constants, the volume and amount of the gas are directly proportional. For example, 1 mole of hydrogen and 1 mole of chlorine react to form 2 moles of hydrogen chloride. So, at room temperature and ambient pressure, 1 liter of hydrogen and 1 liter of chlorine react to form 2 liters of hydrogen chloride. The ideal gas law is a combination of the empirical Avogadro's law, Boyle's law, Charles's law, and Gay-Lussac's law. For any ideal gas, the ratio of PV to Tn is simply a same constant, R. The ideal gas law is often written in an empirical form, PV equals nRT. R is the ideal gas constant. Another form of ideal gas law is PV equals nKBT. N is the number of particles. Kb is Boltzmann constant. The ratio of ideal gas constant to Boltzmann constant is Avogadro constant. Ideal gas law is a good approximation of the behavior of many gases under normal conditions. For example, the molar volumes of many common gases at 0 degrees Celsius and 1 atm are almost the same as ideal gas. A mixture of ideal gases is another ideal gas. The partial pressure is the hypothetical pressure of a component in the mixed ideal gas, if it alone occupies the entire volume of the original mixture at the same temperature. So, the partial pressure of a component complies ideal gas law. Dalton's law states that in a mixture of ideal gases, the total pressure is equal to the sum of the partial pressures of the individual gases. For example, the total pressure of air is equal to the sum of the partial pressures of nitrogen, oxygen, argon, water vapor, carbon dioxide, etc.